Welcome to another video. It's been a very long time since I made my last video, and it's all for good reason. One of which is I've had surgery on my kidney, and it made sure I couldn't really make any videos or work on any projects for the last month. Also, I've been very busy in the first couple of months with the robot project, which I'll show you just a little bit. It's right here. As you can see, more on that later, because this is just a vlog and I'm gonna keep it pretty short. I'll show you what else I've been working on. One of the things I've been working on is this gate driver board. It's a quad gate driver. It's able to drive 4 MOSFETs at 10 amps. I have included the bootstrap with it already. Therefore, I have a high side driver, low side, high side, and low side. 4 variable gate resistors, which I can just plug in to the power supply, and I have the gate drivers separate, so I can use it or change it. The other thing is my bias power supply for the gate driver itself. And as you know, MOSFETs work best, well, most of them work best at 15 volts. And for example, if you have 12 volts or lower, maybe even 4-cell LiPo batteries, they can change from 17 volts about to less than 14.8, and my gate drivers cut off at 15 volts. Therefore, I must make sure the voltage is always higher than 15 volts. So I've made this little bias power supply. As you can see, it's currently at 11.8 volts, and it's stepping it up to about 17. It's very unregulated because there's no load, and currently the driver for the bias supply is the Arduino, and I actually want to use the ADTiny, but it's a little bit more difficult than this one, so I'm testing this one. And if you take a look at the duty cycle on the Arduino, because it's in flyback, this is a flyback converter, and currently it's switching at 37 kilohertz, a very low duty cycle. As you can see, it's changing because there's a feedback loop, and it's not very great yet, but it's making sure it's about 17 volts. And if we change the voltage, I've now changed the voltage to about 15.8, and you can see the duty cycle has even gone lower to as low as 300 millipercent. So that's very small duty cycle, but you can see it's working pretty good. But at the moment there's no load attached to it, so this is just a flyback with feedback, and it's doing pretty good so far, even for a flyback topology. But as I said, I'm going to integrate it with the ADTiny, and as I also said, it's a little bit harder to do so. That's the multimeter, and for now that's basically it. So if I have this working, I can basically drive this one, and this one can drive the MOSFETs, and then it's basically all there is to it. Then I must wind the transformers and such, and I must write the software, so it's getting close. That's basically it. I'll probably see you pretty soon, and thanks for watching. I just freaked out because the multimeter said 400 volts, and that's not correct, at least I hope. If I can see the maximum on that, yeah, you can see 17 volts about, and the minimum 16.3. Yeah, about 70 volts. That's all without load, but if there's a 10 amp load, it's a lot better.